This video goes with this table for investigating rolls of dice. So previously you have worked in class on some problems where you have had to roll two dice and find the sum of those two dice. So there is a way to investigate the theoretical probability of what the sums could be in a very organized and efficient manner, and that is using a table. So anytime that you come across a dice problem where you have to add the two dice or multiply the two dice or anything like that, you need to be making a table. So one of the things that students get confused about when working with dice is whether two different rolls are the same or different. So if you have two dice and you roll a 5 and a 4, some people wonder if that's the same thing as rolling a 4 and a 5. If I just switch those locations, it's the same dice. But here's the thing. The sum of those two dice is 9. If I change this 5 die to be a 4 and this 4 die to be a 5, I still am getting a sum of 9 by adding 4 and 5, but it's not the same number on each of those dice. And it's a lot easier to understand this if you switch out one of the dice for a different color. So in this case, I have a 4 and a 5. When I add those two together, I get 9. The green one is 4, the red one is 5. If I move this to be a 5 on the green one and a 4 on the red die, I still have a 5 and a 4. I still have a sum of 9, but that's a different roll than if I had had this. So those count as two different outcomes. But if I have a 4 and a 4, 1 4 on the green die, 1 4 on the red die, then there's no way that I can switch that around for it to be another different outcome with a red 4 and a green 4 here. So there's no other way that I can turn this one to make a 4, and there's no way I can turn this one to make a 4. So when you have doubles, there's only one way to get doubles. So here's what that looks like on the table. We'll consider the red die as if it's a first die. So what if you were rolling 1 and then rolling the next one? So the red one's going to be first, the green one is going to be second. And so the different outcomes are 1 plus 1. We're going to put plus here, showing that we're adding. So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4, and so on. So you'll see a pattern emerging here. So we have 2, 3, 4, 5, 6, 7. On the next row, 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5, and so on. So we have 3, 4, 5, 6, 7, 8. The next one will start with 4. 1 plus 3 is 4, and then we do 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, 12. So inside this part of our table, we have all the possible sums from 2 to 12. So let's look at what's most likely and least likely now. So at the ends, we have the least likely. There's only one way to get a 2, which is a 1 and 1 on the dice. And there's only one way to get a 12, which is a 6 and a 6. There are two ways to get a 3. You could get a 1 and a 2, or you could get a 2 and a 1. So everywhere we have doubles, like 1 and 1, 2 and 2, 3 and 3, 4 and 4, and so on, there's only one way to get that double amount. But on all the other equivalent sums, like here, 1 and 3, 3 and 1 equal 4, there's two different ways because we can reverse the order of the dice. So when you look for what is most common here, it's the 7s, which you find in the diagonal of that square. So there are 6 different ways that we can get a sum of 7. So the sum of 7 is most likely. there are 6 different ways that you can get a 7 out of a total of 36 different possibilities. So there are 36 outcomes. So that simplifies to a probability of 1 out of 6. We're not going to go through all the rest of these, but we're going to look at a couple. So the sum of 6 or 8 are the next ones likely. The sum of 6 or 8, we have 1, 2, 3, 4, 5. The probability is 5 out of 36, and that can't be simplified. Then we have 4 out of 36 for 9 and 5. 3 out of 36 for 10 and 4. 2 out of 36 for 11 and 3. And 1 out of 36 for 12 or 2. So it keeps on going down there all the way to sum of 2 or 12, 1 out of 36. So one more thing that you need to put on this page in your notebook is sample space. So the sample space is the list of possible outcomes. And when we're talking about the sample space of rolling 2 dice and getting the sum, the sample space is not 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6. It's what the sum would be. So the sample space of the sum of 2 dice, and we use the brackets to show the sample space. So we're going to list out all the different possible sums, and we're not going to list them multiple times if there's more than one way to get that sum. So we don't list 7 6 times. We just list what are all the different possibilities. So we're going to start with 2. So even when we played Tricky Track, we had 1 on the paper, but that wasn't one of the possible sums when we add 2 numbers on a die, so we're not going to include that in the sample space. So 2 all the way up to 12, that's the sample space. Sample space gets a little bit more complicated when there are 2 things happening, like you roll 1 die and you flip a coin, or you spin a 4-color spinner and then flip a coin or something like that. But this is a basic sample space where we're looking at the sum of 2 dice. This all is going to go on the right-hand page in your composition book, where the left-hand page has your probability guided notes.